Good morning, chemistry students. Here are your chapter 16 notes. We will be talking about covalent compounds and covalent bonds. The first section is called the nature of covalent bonding, and we're going to start by talking about molecules and molecular compounds. So we're going to start by defining the term monatomic. Okay. Atomic, hopefully that makes you think of atom, and mono means single. So monatomic means that something consists of single atoms. For example, the noble gas elements are all monatomic because they don't get involved in forming chemical compounds and bonds, and so they always exist as single atoms rather than being bonded to something else. So the difference between ionic bonding, which is what we've been talking about throughout chapter 15, and covalent bonding is that in ionic compounds you have a transfer of electrons, right? The cation is going to give up electrons, the anion is going to accept electrons. In covalent compounds and in covalent bonding, instead of transferring electrons, we're going to talk about sharing electrons. So remember that in ionic bonds, they form when the combining atoms give up and accept electrons. Okay, so the cation is going to give up its electrons. Typically that's going to be a metal. And the anion is going to accept those electrons. Typically that's going to be a nonmetal. That's not the only way, though, that we can form bonds. So another way atoms can combine is by sharing electrons. Specifically, this is going to be called a covalent bond. In a covalent bond, atoms, or a covalent bond contains atoms that are held together by sharing electrons. Okay, and we call that being joined by a covalent bond. So, again, the difference being ionic compounds, there's a transfer of electrons. In covalent compounds with covalent bonds, electrons are going to be shared between atoms. And really, there is a tug of war for these electrons that takes place between the atoms. Bonding the atoms together. So what's holding these two atoms together is the fact that they're both trying to hold on to the same electrons. And because they're both trying to hold on to those same electrons, they end up bonded together. Kind of a way to think about this is, again, to think about two little kids who haven't learned how to share. If there's one stuffed animal that they both want, they both grab a hold of that stuffed animal, right? And they're kind of fighting over it. Realistically, typically a person can come in and grab that stuffed animal and they can kind of pull both of those little kids around because they're both trying to fight over that stuffed animal. Effectively, that's the same thing that's happening in a covalent bond. You have two atoms that are both kind of fighting and holding on to the same electrons. And because they're both kind of fighting over and holding on to those same electrons, they end up bonded together. A molecule, which we're going to refer to a lot, so we're going to abbreviate molecule MOLC, is a neutral group of atoms joined together by covalent bonds. So when atoms are joined together by covalent bonds, we call those groups of atoms a molecule. And we have some diatomic molecules. Now, again, di means two. So a diatomic molecule is a molecule that contains two atoms. For example, okay, oxygen is O2. Now, this is part of Hofbrinkel. And you'll notice in the kind of banner in our Google Classroom and in my actual classroom, there are some posters around that say Hofbrinkel on them. This is because all of these 7 elements exist as diatomic molecules. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine always exist if they're all by themselves as a diatomic molecule. So it would be appropriate to write any of these as with a 2, okay, with that subscript 2 like we've written oxygen. So a molecular compound is a compound made of molecules okay, and they may be atoms of different elements. For example, water is a molecular compound, okay? And so if we're talking about water as H2O, we can say it's a molecule. We also can say it's a molecular compound. We can say that it has covalent bonds in it. So how do we represent these molecules? We use something called a molecular formula. Layla, stop. The definition of a molecular formula is a chemical formula of a molecular compound. So it's just more specific. We still could refer to this formula for the molecular compound as a chemical formula. But by calling it a molecular formula, we're communicating a little bit more information. We're communicating that this compound is molecular in nature and has covalent bonds in it. A molecular formula shows how many atoms of each element a substance contains. So one of the things that you can tell from a molecular formula is how many atoms of each element are in the compound. In a molecular formula, there is a subscript that is written after an element's symbol, and that subscript indicates the number of atoms of each element in the compound. We typically don't write ones. Okay, so if there's no number written, it's a 1. These molecular formulas reflect the actual number of atoms in each molecule. So, unlike an ionic compound, molecular formulas are not necessarily the lowest whole number ratio. One of the problems with a molecular formula is that it doesn't tell about the molecule's structure. So it doesn't tell you about its arrangement in space. It also doesn't tell you which atoms are bonded to one another. We'd have to look at the molecular structure to know the arrangement of the atoms within a molecule. So kind of what I'm talking about here is this idea that if we asked some little kid to draw water, they might say it's an H connected to an H connected to an O. And hopefully you realize that's not what water looks like, right? Water is an oxygen connected on two different sides to hydrogen. But this is the molecular formula for water. And it doesn't give you any information about which atoms are bonded to which atoms. So that's sort of a problem with a molecular formula. So we kind of want to compare molecular and ionic compounds, what might be the same about them, what might be different. Okay, so the representative unit of a molecular compound is a molecule. And when we talk about representative unit, we're talking about if we had a big chunk of molecular compound, what's that smallest piece we could chop it up into and it still would have all the properties of that big chunk? That smallest piece for molecular compound is called a molecule. For an ionic compound, the representative unit is a formula unit. And for an ionic compound, that formula unit is always the lowest whole number ratio. Molecular compounds have relatively low melting points and boiling points, which means that they are often gases or liquids at room temperature. And molecular compounds, we are always going to say, are made of two or more nonmetals. So that's how we're going to identify a compound as being molecular. Ionic compounds, by contrast, have high melting points and ionic compounds are made of a metal and a nonmetal, or they contain a polyatomic ion. And so those differences are going to be really important to us, because we're going to discover as we move into Chapter 6 that there are different ways we write formulas depending on whether a compound's molecular or ionic. And there are different ways that we name the compounds depending upon whether the compound's ionic or molecular. So this here, that molecular compounds are made of two or more nonmetals, and that ionic compounds are made of a metal and a nonmetal or contain a polyatomic ion, is going to be super important that you recognize and know as we move forward. So back to focusing a little bit more on molecular compounds, and specifically single covalent bonds. Okay, we're going to define a covalent bond. Okay. So, in covalent bonds, electron sharing usually occurs so that atoms attain the electron configuration of noble gases. So, just like ionic compounds and ions are trying to be like a noble gas, okay, in covalent compounds or in molecular compounds with covalent bonds, the elements still are trying to be like a noble gas. But unlike ionic compounds where they're going to be transferring electrons, in these molecular compounds, they're going to be sharing electrons to do that. So to look at an example, if we look at hydrogen and its kind of electron dot structure, right? I have two hydrogen atoms, and I'm going to represent my electron on this other one as an X so I can just kind of track what happens. And these become a compound like this. Remember, okay, hydrogen this way gets two electrons like helium for both hydrogens. So this way, by sharing these two electrons here, both hydrogen atoms feel like they have two electrons like helium, the noble gas. And what really kind of holds these atoms together is that attraction of the shared electrons to the positive nuclei of each of the atoms. So those shared electrons are attracted to both the hydrogen on the left's nucleus and the hydrogen on the right's nucleus. And again, they're both holding on to those same electrons, so that bonds those two hydrogen atoms together. Specifically, a single covalent bond occurs when two atoms are held together by sharing one pair of electrons, right? Which means two electrons total. An example of this is that hydrogen we just looked at. Okay, that's a single covalent bond. You can also represent that bond with a dash. So when we have a dash, that means that we have a sharing of two electrons. This is called a structural formula, and this represents the covalent bonds as dashes and shows the arrangement of the covalently bonded atoms. For example, a fluorine, which would have 7 valence electrons, and another fluorine, and again, I'm going to represent my electrons this time with X's just so that I can kind of track them. They come together and form a covalent bond. Okay, or I can draw it with those electrons that are shared between the two atoms as a dash. So that's called a structural formula. So the chemical formula of covalent compounds describes molecules, and they are called molecular formulas. Molecular formulas, again, show the number of atoms, but it doesn't tell the structure. Examples that we've looked at would be H2F2. Okay? Now, with those, it tells the structure because hydrogen's bonded to another hydrogen. But when you get into more complicated or compound, even like water, it doesn't. And molecular compounds are always following an octet rule for covalent bonding, which basically just says that electron sharing occurs so atoms get the electron configuration of a noble gas. So these elements still are trying to be like a noble gas, but instead of transferring electrons like what happens in ionic compounds, they're going to share electrons. Your homework then is on page 451, questions 7 and 9. Have a good day.